Okay, so this time we're gonna have another example regarding the algebraic substitution. So say we have to evaluate the integral of 9 plus square root of 9 plus square root of x d of x. Okay. So our technique is to let the some variable, say u, equal to the complicated part in our integrand. So first, let's ano pala muna, let's rewrite this in terms of power, which is 9 plus x raised to 1/2, right? And then the all this term is inside the square root sign, so need to raise it by 1/2 and then d of x. Okay, so let's go back here. So let u is equal to this is the hardest part here, so let's take u is equal to 9 plus x raised to 1/2, and then we can now substitute u in this form, so we will have a u raised to 1/2. But how can we find the value of d of x? Okay, so let's try to take the derivative of this. U is equal to derivative is 0 plus 1/2 x. 1/2 minus 1 is negative 1/2 d of x. So you can see here, instead of having our dx, we have here also a complicated part, which is x raised to 1/2 dx, and we don't have that on our original integrand. So let's try to think of another way wherein we can find only the dx. So say let us erase all this term by 2. So we have u squared plus, is equal to 9 plus x 1/2 squared, wherein our u squared here is to it in the other way, so we were not able to so we can now separate our x. So let's first move our constant on the other side. So we have minus 9 is equal to x raised to 1/2. Then let us raise all this term by 2. So we have u minus 9 squared is equal to x, right? So from here we can now differentiate so that we can find the d of x. Okay, from here we have 2 u minus 9, then the derivative of this is du, right? So we have 2 u minus 9 du, then that is equal to our d of x. So now we can now substitute all our values. So we have u, and then our dx is this one. Okay, so from here, from 9 plus x 1/2 raised to 1/2 dx is now equal to the integral of this part here is u, but is raised to 1/2. So we have u raised to 1/2, and our dx is this one. So we have 2 u minus 9 du. Okay, we get 9. Okay, so let us simplify our integrand. So we have u 1/2 times 2u minus 2 times 9 is 18 du. Then you can now uh, multiply the u raised to 1/2 to our term this, so that our integrand will now become 2 u 1/2 times u. We have 1 plus 1/2, we have 3 halves, right? And minus the du minus the integral of 18 u 1/2 du. Okay, so from here we can now easily perform the integration using the power formula. So we have 2 u 3 halves plus 1, or 3 halves, we have 5 halves. So this is all over the 5 halves, minus 18 u 1/2 plus 1, we have 3 halves, so all over 3 halves, and then our plus c. Okay, simplifying it further, so we have 2 times 2, we have 4 over 5 u 5 over 2 minus 18 times 2, we have 36 all over 3 u 3 halves plus c. Okay, and we need to bring back the value of u, wherein our u is equal to 9 plus square root of x, or x raised to 1/2. So our u is 9 plus square root of x, and then this raised to 5 over 2 minus 36 over 3, 9 plus square root of x raised to 3 halves plus c. So this can be our final answer, or you can simplify this by dividing 36 by 3. So we have 4 over 5, 9 plus the square root of x, 5 halves, minus 36 divided 3 is 12, then 9 plus square root of x, 3 halves plus c. Okay, so once again, from here, the square root of 9 plus x, square root of x dx, we write this in terms of power by transforming our square root sign in terms of power. And then we've got this 9 plus x raised to 1/2 all over raised to 1/2 dx. Then we let our u, because this is our complicated part here, equal to 9 plus x 1/2. And then we do some algebra, and we got the square of this both sides. So we have u minus 9 all over raised to 2 is equal to this part here is x raised to 1, or just x. Then we find the derivative of this, so that we can substitute algebraically the value of our dx in terms of u. So we have 2 multiplied by u minus 9. Then we've substitute all the values of u in our equation. So we have this one is u raised to 1/2 times the dx, which is equal to this whole part here. Then we've simplified by distributing. Then by separating this whole to integrand here, we can now perform the power rule. And then we bring back the value of our u, then we simplify.